In this lecture, I will introduce you to how to use 3D photogrammetry. What is 3D photogrammetry? Essentially, it's very simple. We take a sequence of photos walking around an existing object, trying to photograph every detail we would like to be turned into a 3D mesh. And then the images we will use with a software to then create, you guessed it, a textured 3D model. And then that mesh can be placed into any program. Here, the Thermometer is inside Blender, can be loaded into Fusion, anywhere that can load the mesh. And then we can use this as a three-dimensional blueprint to, for example, create then a nice and clean version of it. This is also an amazing tool when you have a form model you would like to prototype or an existing object you would like to digitize. It beats hand measurement and then trying to transfer that into a 3D program, which is labor intensive and prone for errors. And via the photogrammetry process, it's literally a matter of maybe 10-15 minutes and you're done. Okay, so the software we will use for this process is Metashape from Agisoft. I work with over the years with multiple solutions from Autodesk and others, and Metashape has few advantages. It's Mac and PC. It is very easy to use. It is actually very fast and effective, and also cost-wise for professionals as well as students, it's not really that expensive. For this class, we will use the 30-day trial version. If you then want to buy it, it's just around $50, I think. So it's not really that expensive. Consider the amount of time you might save compared to hand digitizing an object based on a prototype you made in a woodshop or so. So you can download the program for Mac and PC, and I will talk a little bit about how then we do the photos, because the photos is really the heart of this whole process. Good photos, good result. Bad photos, bad result. So you might ask yourself, what's going on here? So what does photogrammetry not like? It does not like transparent objects. It does not like glossy surfaces. It does not like uniform colored surfaces. It does not like photos which are where the main subject is out of focus, and it prefers soft illumination, and it does not want to have bright objects or lights in the backdrop. So the thermometer is made out of a white plastic and it's kind of glossy. So I needed to fight the problem of this whole thing being just white and also being glossy. What I used here was simply use some cinnamon and I sprinkle it over it. That helps the software to see more the geometry. Otherwise, it would just see something that is white. Plus the cinnamon or the spice, whatever you will use, also helps fighting to a certain degree the glossiness. You can see the glossiness right here where this reflects actually the light from the window, or the same here. This is kind of like a low-key process, but from my experience over the years, this actually works really well. If you do not want to use this process because it can result into slight grain in the mesh, you can also buy a can of dry hair shampoo. That works wonders, but the can is also $8, so it's not that cheap. Instead of the can dry shampoo, let's say you have a glossy black object you would like to digitize, you can also use cornstarch and like sprinkle it with a sifter or so over it, or a strainer. So you also see this object is elevated off the ground. The reason why I did this, it helps to separate the object from the paper. and I will end up with a really nice sharp edge. So I started taking the photo from the side, and then I slowly walk around. And there you can see there's a reflection of the sun, the window. So I try to keep this out of the image. I try to frame my object as much as possible. The more pixels the thermometer occupies, the more pixels the software can work with and use it to create a mesh model. Really important is keep as much as possible your object in focus. You see this one is slightly blurry. Unfortunately, there's no way to get everything in focus because I'm using an iPad here and I need to get a little bit closer. You can also, when you have an iPhone or an Android with a telelens, use a telelens and you can be a little bit further away and zoom in, and your body might not block the light actually on the object. So there here you see I walk around. When we go to a side view, then it's very easy to have the whole object being in focus, but when something gets diagonal or more perpendicular, it's just a struggle. But the software will understand where I focus on and use that basically for the mesh generation. Okay, so you see one very simple 360-degree pass around. Let me show you a different trial I did. Here I put the object onto a box and then walked around one more time. Also notice here there was quite a jump. It's also a little bit of blurriness here, which is not very good. This is focused, not this, but I should have looked more on this part. And then once this pass is done, then I take a look from the top, make another 360 pass. The goal here I was trying to do is capture everything as much as possible. And then to even add more definition, you can go in and take photos of certain elements. And the software will, based on matching the images, understand where all these images relate to. To bring this to an end, the software can only generate geometry of the object that you have photographed. Now, if you don't supply photos of something, it cannot do generate the geometry. And before we jump into MetaShape, the way now how 3D photogrammetry works is the software takes a look at this image and tries to identify where are here very easy to identify features I could memorize. And then I go to the next image and then do the same and then compare. So here and here, where do we find matching elements? Now, for example, let's focus here on the triangular warning sign, where it is in each image. So there are 3 positions in the image. The software will be able to understand what camera is being used, what's the focal length. It will calculate the position of the camera in 3D space. And then think about like its basic triangulation, like stereo vision. If you look through your right and then through your left eye, this is kind of like how we judge distance. The software does pretty much the same. Okay, so let's go to MetaShape. I won't start it. The software is super easy to use, which is why I love it. Lots of menus and icons, no big problem here. Later we will have our asset, there's our 3D view, some tools, and first thing what we want to do is add photos or add a folder. So I go to add folder, and then here you see all these images. Click open, and then now here it says, and it has all these images. I will open the pre-existing file I have here, so you can see the results. Okay, so there we are. So at the beginning, you will see only the photos. And then the first step would be align photos. Highest is fine. Click OK. Based on your computer, takes a moment to calculate. And then you will see something like this. So these are, for example, these features the software tried to identify and then relate. You can see that some are also outside, further away. Then to clean everything up, we could use the rectangular tool, draw over our object, and then we say crop. And then you want to go to here and set reset region. This basically means that the software only focuses on this volume inside this box and all the points which are inside. Okay, so then the next step would be build mesh, and the source is depth map. Quality high is fine. There's ultra. You can use ultra. I never really found that it really adds that much more detail to it, and it takes very long time. If you don't know if your images are good, you can also start with a low quality, then the processing time is faster. And then if you see no problems in the resulted mesh, meaning your photos are good, then you can go back and do this one more time via high and click on OK. And then it will take a moment to process, and then we will end up with a solid model like this. There you can see this now. Okay. Now here you can clearly see we did not take photos of the area below, so the software will have filled stuff in. Here also you see this is kind of washy because that is actually red glossy plastic, so it gets completely confused. Now you can see how bad actually the spice containers are transferred, but our thermometer is actually pretty good. You can also see here the nice sharp edge, which is perfect, which is why it was good to lift this one up on top. So the object then actually would look like also this, no? So the texture is a little bit blurry. Okay, the last step then would be build texture. Simply click OK, and then it would create a nice, precise UV texture for this object. So we then load this design into Blender. Then we can also see this texture on it. That's also why I like doing this type of modeling in Blender, not in Fusion, because Fusion can import the geometry, but it skips the texture, which is really annoying. The texture here really helps also understanding where is the seam here. Okay, very good. When you're then done, all we have to do is go export and export model. Just export it to there as wavefront OBJ, save, and this is all correct. Click OK, and it takes a moment, and there it is. Good. Now I will open the other process I did just to show you what happens with a different set of photos. Oh, where did it go? Let me just open this one more time. Oh, I just turned this one off. There we are. Okay, very good. So in this view, it looks actually pretty good. But if we turn the texture view off and go just to the solid mode, there you can notice how difficult it is to understand where does this object separate from the ground. So we also show the textured part. Now there, it is kind of there in the texture, but it's not so easy to see in the mesh. Also, interestingly, when we go back to here, you notice that this area there's kind of like some bloppy stuff on it. And we even took more photos of this area. And there you can see it looks like a cavity. So it did not really transfer into better images. Sorry, the more images I took did not transfer necessarily into a better mesh model. Maybe the photos were not as good. This process took a lot longer to calculate because I have quite an amount of photos, and here this was just one single task, and yeah, as you can see, looks really good. So that's another thing I really like about Shape. You can get away really with a low amount of photos and get a really superb geometry from the result. And that basically is how you do the photos and then use Shape to create then those 3D scans.